6.3 numerical model. What is a numerical model? So a numerical model is a form of quantitative data. So it looks at speed, velocity, time, displacement. That's that stuff. And this is all factual. So it uses numbers and stats to analyze a performer. So this isn't opinion based. So it's a very factual way of collecting data. You can form a numerical model by using many different sources. So there's many ways to study to produce a model or the perfect model. And so a specific athlete from like elite athletes, they might have a different technique, which in something like the technical model would be a factor to consider, but since they have a different technique, they could still be getting a good statistic and result overall, which is what this numerical model looks at. You can use a variety of literature, elite athletes, and looking at different findings on it and research papers, for example, to find a suitable model. For this presentation later on, we used NBA data to assess a performer, which would be good as it's from elite athletes, so it's what the best people are able to do, which what a performer should be looking at going off. But as a teenager, they are unlikely to be, or almost impossible to be, reaching those professional standards. So it's more realistic if you were to use normative data from their age group. And this could be done by recording or looking at digital images, or measuring and producing a model by scaling, for example. And there are many different components to look at in a numerical model. So it could be looking at linear motion, angular motion. So linear motion's going in straight lines, for example, straight planes. Angular motion is moving around a plane, and so that could be pivoting in basketball, something. And projectile motion, that would be something like the ball travelling to the hoop in a basketball shot. As the basketball is the projectile. And we're just looking at linear motion for this presentation. It's important to know the difference of kinematics compared to kinetics. So kinematics is analysing the properties of motion of a body. So that can be either linear or angular. And when it says a body, that could be a basketball player themselves, or it could be the basketball. So a body is just an object. And this differs to kinetics, as kinetics is studying the forces used to create movement of a body. So the kinetics is specifically looking at the resultant forces that causes motions, and this includes Newton's laws of motion, which we'll look at later on. First, looking at forces, there are four main different types of forces. So you have internal, external, vertical, and horizontal. So internal forces are generated from the muscles in the body, and then this is then transferred into external forces from the contraction of muscles. So for a basketball player here dribbling, their muscles are working produce internal forces, which then causes their legs to put downwards pressure or a downwards force onto the ground to then get a reaction normal force which pushes them along the court so they can run and dribble across the court. And obviously their external forces could be something to do with the performer, but it could also be a constant such as air resistance or gravity, which will always be working on them and in some aspect or another. But this is air resistance and gravity are variable depending on different factors. And then from these external forces, they can be categorized into either vertical or horizontal forces. So gravity would be a vertical force as it's pulling them down towards the ground, and a horizontal force could be air resistance, for example, or it would be their plane of motion would be a horizontal force as they're trying to run down the basketball court. And then when forces are applied, they have different effects on the body. So one effect could be it starts from rest and generates motion. So if this player here caught the ball, they'd be starting at rest. They could jump and catch the ball at rest and then begin to dribble with the ball. That would be because their forces in their legs and their muscles have began to push at the basketball court floor to generate motion, which kind of links to acceleration, as they've gone from a starting velocity of 0, and then they're increasing their velocity over time, which links to acceleration. Looking at the acceleration, they could also go from a set speed to an increased speed. So the basketball player could be dribbling down, as we've been talking about, and they then accelerate, so increase their speed to try to get past the defender or put the defender off to make them off balance so that they can get around their defender easily. That's the same with deceleration. So you just less force is applied or more force is applied in the opposite direction to where they are moving. So that means the resultant force will then be in the other be decreased as more force being applied in the other direction, meaning that they will slow down. They could also change direction. So if the resultant force completely changes opposite direction, for example, they could do a fake movement or a fake pass and then quickly run off to the other direction. They'd be applying a force to shift in direction to get past the defender and put them off. And also changing shape. So the ball, for example, when it's applied a force downwards to bounce and dribble the ball, as soon as the ball hits the floor of the court, it would change shape slightly as it rebounds up back to the player which has the ball, and that just allows it to bounce and be able to dribble. Looking at Newton's 3 laws of motion now. The first law of motion about inertia, and this is about a body will continue to travel unless an equal or greater opposite force opposes it. So a body will travel in the direction of the resultant force. So if the force applied here is greater than the friction here, it will continue to move to the right in this diagram. And this can be applied in basketball, as it would then be harder to get past a larger defender, as more force is required to overcome their weight as weight is calculated by mass times gravity. So mass would be bigger as they're a larger player, meaning that more force will need to be applied against them as an attacker to be able to get past them, because they would have a greater force of gravity and a slightly greater force against the force you as a player are applying on them. So that means, and this compared to if it was a smaller player, they'd have less mass, so their weight would be less, meaning that their force against you as a player would be reduced compared to that larger player. And this would be a constant thing overall. So, for example, if a basketball was rolled or thrown, gravity and air resistance as they're thrown to shoot slows the ball down. Otherwise, it would constantly just continue to move in that straight linear motion, which is what causes it to have angular motion. The second law of motion, of acceleration, and this means that acceleration is directly proportional to the magnitude of the net force, meaning that as the net force increases, the acceleration also increases, which is given by the formula F equals ma, which is force equals the mass times the acceleration. This also means that acceleration is inversely proportional to the mass of a body. So as acceleration, if force is constant, and then as acceleration increases, mass should decrease to keep the force as a constant. This can be applied to basketball as a basketball sprint, so a fast counter-attacker play. A smaller, lighter performer with less mass, if they can produce the same amount of force as a much larger, heavier player in the opposing team, the smaller player would actually get to the ball first, as they would have a greater amount of acceleration, as both players' force is constant, meaning that the larger player would have a reduced amount of acceleration compared to that smaller player. So this would be beneficial, but unlikely, as a bigger player likely to be able to apply more force due to a larger power output from their muscles. And finally, the third law of motion is actions and reactions. So an applied force will receive an equal and opposite reaction force. So looking at this diagram of a tennis ball, this could easily be recreated as a basketball being bounced. And so there's a downwards force that's being applied through a dribbling in a basketball. And the ground is applying a reaction force, which then ultimately makes the basketball bounce back up again. But this applies equal reaction force, so that the body of the ground doesn't move, and the basketball will only bounce back up as it has much less mass compared to the ground, which is connected to the whole earth. And then obviously this is assisted by gravity moving down when dribbling.